All right, hello again. We're going to do multiplexers this time. Basically, what we're doing with our multiplexer chip, our 74150, is we're taking our Boolean expression, we're putting our min terms in and getting a high out. Kind of like what we do with when we did our Boolean expression. We're trying to figure out which ones were our min terms. Those are the ones we know we should get a high out. Everything else we should get a low out. Same thing we're doing here. The only difference we got here is pay attention. Instead of A, B, C, D, we did D, C, B, A, which means D is now my most significant bit. A is now my least significant bit. So what I'm going to do is I'm going to look at my Boolean expression, and I'm going to do the same thing I did for my Boolean equations, my K-math. If it's got a naught, it's a 0. If it doesn't have a naught, it's a 1. So 0, 0, 1, 0, 0, 1, 0, 1, 1, 0, 1, 1. These are my min terms. These are the ones I should get a high out when I put them into my multiplexer. And I can figure out what they want to be. If you guys want to figure out the digital equivalent, you can. That way you'll know, okay? But when we wire up this chip, okay, one thing, we got pin 9 here, says it's a strobe must go to ground. That is a strobe on this chip. In order to enable this chip to work, we have to tie pin 9 to a ground. If we forget to do that, this chip's not going to work. So we're going to take pin 9, we're going to tie it to a ground. Then we're going to take pin 12, which is our ground. We're going to put that on the ground. And we're going to put our pin 24, which is VCC. We'll put that to our 5 volts. Okay. Our E0 through E15, those are going to be the numbers 0 to 15 in binary. Okay. What we're going to put these in is we're going to use our selector switches, S3, S2, S1, and S0. With S3 is our most significant bit, which would be D. S0 is our least significant bit, A. So if I want 0, 0, 1, 0 in there, I'm going to put 0, 0, 1, 0 on my selector switches. Well, that gives me what? 3. So it's going to go to 3. That's going to be one of my, or 2, sorry. That's 2. So it's going to go to 2. That's going to be one of my min terms. Well, since I have a inverter on my output, I need to tie this to a low because I need a low here. It's going to invert it. Yes?
Pin 6.
Pin 6. Oh, sorry, pin 6, not pin 2. Pin E2 means 0, 0, 1, 0. So I'm going to tie pin 6 to a low, which is going to give me a low here. It's going to invert it to a high, and I tie this to my light, and my light come on. And I do the same thing here. I go 0, 1, 0, or 0, 1, 0, 1, which is 5. So I go 5, which is E5, pin 3. I'm going to tie that to a low. 1, 0, 1, 1, which is 11. So I'm going to find E11, which is here, and a pin 20. I'm going to tie to a low. All the other pins I'm going to tie to a high because then if I have that number in, it's going to put a high here, give me a low out, and my light will not light up. I don't want my light to light up except for these 3 numbers. That's all the multiplexer is doing. This should be a very simple and quick lab. I think there might be maybe 5 or 6 numbers in your actual Boolean expression on your lab that you're going to tie to a low. Make sure you get your light to come on. That is all there is to it. Have fun with this lab. It should take you all about 10 minutes. Bye.